So today we'll see piecewise defined functions. So what are piecewise defined functions are like we define the function in some intervals. You can see this that fx is defined as x for the interval x varying from 0 to 1, but it is defined as 2 minus x for the interval 1 to 2. So we'll try to make the graph of these following functions one by one, and we'll understand how piecewise function defined functions help us to make lots of different kinds of functions which can be easily expressed. Okay, so we'll see how we'll do that. So now we'll see the first example, which is fx equals to x, and we have it defined from x is 0 to 1 and then 1 to 2. So we'll first make the x-axis and the y-axis for this particular function. So this is x, this is y, and you need to draw the intervals. So suppose it is from here it is 1, and here of course it is 0, and here it is 2. Okay, and we'll also mark from here as well. So it's suppose 1, and here it is suppose 2. So now you can see that if you see, this is a linear function and this is also a linear function. So we can draw the points for different parts of this graph, and then we'll join them to form a linear graph. So if you see in the first one there is x, so I'll switch the value of x to 0. So 0, we get the fx as 0. So the first point is this one. But when it comes to 1, it will come back to 1 because fx equals to 1. So now we have the another point. So we just join them. Then we have the interval 1 to 2. So now we'll write x equals to 1. So now if you write x equals to 1, fx is again equal to 1. So now one point is this one only. So now I'll plot that point. Then we have another point for this particular graph. So I'll take the point 2. So again you get the value as 0. So now I'll mark it as 0. So now the point is this. Now I'll join these particular points, and now we have this graph of f of x. So now this is how we define the piecewise functions. Now we see another example of g of x. So now first of all we make the coordinate axis, and we define the coordinate axis, and we have the points from x equals to 0 to 1 and then 1 to 2. And we also have points in the y-axis as well. So now we make it 1 and make it 2. So now you can see that these values are in the linear format. So if we just get the points, we can get the values of y for particular x. So now since we take it from 0, so I have the point 0, 1, x equals to 0, 1. So this is one of the points. And another point is at x equals to 1, gx becomes 0. So we have this point as our next point, and we just need to join them because since it is a linear graph. Then we have another example, which is 2 minus x, which is from x is 1 to 2. So we just write x equals to 1, then we get gx as 1 again. So now we'll mark it as this point. And then again, if we go to the point 2, if we write it, it becomes 0 again. So now I'll mark this point as 0 and this point as y equals to 1, which is g of x equals to 1, and just need to join these particular points. So we have this coordinate is not included, but this coordinate is included. So just remember this, then when the points at the continuity where the function definition changes, we just need to remember that which point is included and which is not. Now we have this function fx equals to 4 minus x square where x is less than equal to 1, and another piecewise defined function is x square plus 2x, which is defined for x is greater than 1. So these kinds of functions which are not linear in form, we can just try to make the graph of these particular functions individually. For example, this function and this function. Individually make the graphs of this. So I'll tell you how to make the graph of individual functions as well, and also I will explain how you can combine them to form a piecewise function, which is f here. Okay, so now how we'll do that, we'll see. Okay, so first of all, I'll make the graph of this, then I'll make the graph of this, and then I'll explain how I made them. Okay, so I'll do that. So first of all, make the coordinate axis, and we have a graph of this particular function, which is from here to here. So this is a parabolic function. Okay, so here this point is 2 comma 0, and here it is minus 2 comma 0. And again we have another function which is like this, and which looks like this. And this point is minus 2 comma 0. But since we have to define the function from x is less than equal to 1 and x is greater than 1, so we need to plot these points. So I'll just plot this point as this point as 1 comma 0, and this is 3 corresponding to 0 comma 3. Corresponding to 1 comma 0 we have 0 comma 3. And in the same case, if we go here at 1 comma 0, we get again 0 comma 3. We put just x equals to 1, we get 3. Okay, so now we just combine these two graphs, and after combining you'll just see what I am showing here right now. So now the graph will look like this. The graph will go from here all the way up to this point, and here if you see here it will be 1 comma 0, and it will go up to x is less than equal to 1. You can see from the example, if we go back, it is all x less than equal to 1. But since the definition changes from here to here, x is greater than 1, then the function is defined as x square plus 2x, which is this particular graph. So now if you join these two graphs after 1 comma 0 and you just try to plot it, you'll get this kind of graph up to infinity. So this is how we draw the function for x equals to greater than 1 and x equals to less than 1, which are defined differently. Okay, so now we'll see another example, which is g of x. Okay, so now I'll try to explain how g of x is defined, and we'll draw the graph of these particular functions so individually, so that we can combine them and form our required graph. Okay, so now I'll draw the coordinate axis. And since 1 by x graphs look like this, and the graph of x, y equals to x, looks like this. But since we have to get x greater than 0, we'll remove the parts that are not required. So we'll cut this part. And then we also do not need x greater than 0 for 1 by x graph. So we'll just cut this particular graph. And now we just join them to form our required graph, which will look like this. I'll just show you how it will look. So now it will be for x greater than equal to 0, it will be simply x, and for less than 0 we'll have the graph which will look like this. So this is how the blue graph is g of x. Okay, thank you.